Hey, hi all. I am Ranjeev, and I am currently working as a senior data engineer in Rockwell Automation. Today we are going to deep dive into Databricks. So you can learn about Databricks from its document itself. You can go to docs.databricks.com and could directly refer to all the like how could you sign up for Databricks free workspace? How could you deep dive to the different queries and the notebooks, workspace UI, and other things. Today we'll start with some demo. Like I built some web page to just to start. Just to give you an idea that what is Databricks and how could you start with it. Like and also I will go further into Databricks architecture, like the basic architecture, just like we are not completely deep diving into the core memory, that how the memory allocation is done, but I will get a basic idea that how the partitioning does happen and how the clusters. Uh, what's the impact of a different cluster, the cost and everything, and also further we'll see the basic UI from Databricks itself that will help you to understand. Um, it will help you to understand that how the workspace does look and what you can do with the Databricks environment. Okay. So first of all, I'll start with why do we need Databricks? Like what was the requirement that the Databricks came as an idea. So earlier, like used to have data lake and data warehouse work in silos, and for example, data lake is something that where you can store the raw file. In Amazon, we have S3 bucket, and in AWS, we have AWS Gen 2. In GCP, also, we have similar data storage. So, data lake is something that we could store the raw files. It could be like there's no quality check and something. Data warehouse is something that where you have structured data and use the data for like BI visualizations, building visualization dashboards or something. Um, The problem in data warehouse is a bit expensive, and you cannot store the unstructured data. And you can and for the email purpose, like sometimes you need the raw data for processing, so you cannot directly use the data warehouse as uh, a data warehouse for the email as well. So Databricks comes as a unified data analytics platform. Okay, that eliminates the need for moving data around. So here you can see a graph, right? Where we can see that the impact of Databricks, like it helps to reduce the data latency, data duplication, the email readiness. For the email readiness, you can see that we can rely on Databricks itself rather than traditional silos. And even if you go to database documentation, and if you can just go for the basic Databricks, like what is Databricks, you can see like it's an unified governance where you have a complete control of your data. You can build an ETL and real-time analytics pipeline and orchestration tools, and you can manage everything from a single workspace. Okay. Now coming back to the what is the lake house? Like earlier we mentioned that Databricks is a unified data analytics platform, and it could be considered as a lake house together. So what do you mean by lake house? Like if you combine data lake and data warehouse together, um, so suppose you have the control of the data lake, the storage capability of data lake, okay, which has benefit of low cost and is highly scalable as well. And if you combine the benefit of data warehouse as well, that where you get the benefit of ACID transactions. For example, when we are talking about ACID transactions, so here A stands for atomicity, C for consistency, I for isolation, and D for durability. Atomicity means like all the transactions that is going through. Okay, either it will happen or it will not. So if the transaction got failed, it will revert back to its original state. For example, you can imagine that you are doing a banking transactions, and if the payment transaction got failed, the money got reverted to your account. It's just an example, so you can relate with it. Consistency is something like all the transactions that follow a certain rule, like this predefined rule, and all the all the conditions that you have already defined. Isolations means like all the all the transactions that you are currently doing. Okay, so no, if the two transactions are going through the same at the same time, they should not interfere with each other. That means each transaction should be happen in isolation. And durability means like whenever any change commits are done, and whenever any changes has already occurred, the data has, whatever data that's been write to the memory into database, that is, that is basically stored in in the database in the hard disk, and even through any like if any calamity will occur, data will not be lost. So that means durability. Schema enforcement, like if it does check with the data type and predefined schema, and it does validate like whether the data that's been written to the memory does meet the valid conditions or not. With the database, you can do time travel as well. That means you can refer to the previous history of the data. Like you can query the history of any table, and you can see that what changes has been done at what time stamp. Also, you can use the benefits of database streaming, where single API could be used for both batch processing and real-time streams as well. Now coming back to the platform architecture. So in Databricks, we do have you can imagine that the cost part is basically being maintained by your cloud interface, either it is AWS, Azure, or GCP. Whereas there are two sections: one is control plane and one is data plane. Data plane is something that's maintained by your cloud interface itself. Databricks just control the workspace UI, the notebooks that you are building. You have benefit of job scheduler and all. Though both are related, these are maintained separately together. So you can create a cluster inside Databricks, but the cost part is being handled through the cloud, from the cloud side. And similarly, you can connect to your cloud object storage, such as S3 or ADLS Gen 2 or GSS in GCP. But again, the cost part is being maintained by the cloud side. Okay. Now, okay, this is the medallion architecture that Databricks follow. Like, this is a basic architecture that everyone should be aware in data engineering side. So, what do you mean by bronze layer, silver layer, and gold layer? So, when we talk about the bronze layer, like you can imagine the same data, the raw data that's been processed from Kafka or any other streaming tools or any other batch processing, and the same data, the raw data, that sits in the bronze layer. Okay, it could be used for the email process, like so for some email models, we need the raw data to fine tune the model and all. So that's the need of bronze layer. In some cases, we need the filtered data, right, for some to build some dashboards or build do any kind of analysis. We need the filter data. So this is where the data just sits in the silver layer, and the gold layer is something like if you are finding a data as per business need, this is like gold layer we can consider. So usually like gold layer has less tables as compared to silver layer, and the same does continue with the bronze layer as well. Yeah. Now we'll come to the compute. We'll see like how the cluster can create the cluster. Not create, but you can just I'll show you like how what goes inside the cluster as well. This is basic example. Like we have different form of cluster. The two of them are all-purpose and job compute cluster. So if you are, what's the difference between them? So if you are just doing some analysis, you are building a notebook you should go with all-purpose compute cluster, where which has benefit of like I mean it just comes with higher cost, but you can use it with your the notebooks that you are building. Whereas job compute cluster does come with least cost as compared to all-purpose plus compute cluster, and it should be used for the all the scheduled pipeline. So suppose if you have some pipeline in the process where you are doing some ETL transformations and loading data into the sink from the source to the sink transformation. So you just want to schedule a pipeline in all together. Okay. So for such cases, you should use the job compute cluster. They are multiple. I mean, you can compare the cost here. So, in this example, we are considering that we have one executor and one node inside a cluster. So if you can check that if we are running the cluster for 1 hour, so job cluster, compute cluster does take for $2 of whereas the all-purpose compute cluster costs around $5. And similarly, if we can increase the timeline, the cost does vary. Okay. Databricks does have Unity catalog. Like it is, I mean, you could understand Unity catalog as a unified governance layer where you can control everything. You can control the access to uh, like its meta store catalog. This, I mean, either the schema table. You can, if you want to just share a single schema or any single table data with someone, you can do that using the data catalog, Unity catalog. There are some best practices that could be followed, that should be followed. Like you should use repo. So in database, you could create a repo and like you can just sync it together. You can sync, you can so that if multiple developers are working on the same notebook, their changes are their changes does not affect others other changes. Okay. It does regularly compact small files. I mean, this is the best practice that should follow. We should all have to follow. We should all can follow in our day-to-day practices. Like if you have some small files and those tables are not being used and those are being used as a cold storage, you could delete those tables. Okay, or you could also, if you're creating cluster, okay, there are some, as you can see that there are some costs associated with the time that you are running the cluster. So in such cases, if you're not using a cluster, you can set auto termination in the cluster. We'll see that in practice as well. But for now, I'll move to the next PS that I built. So this one you can understand. I'll go to back to document again. So you can see here the data architecture page. Okay. And if you go back to the high level architecture, you can see like if on the high layer, okay, there's one account, there's one service account that controls the meta store, workspace, and in the workspace architecture, we have seen the control plane and account plane. So this is something that we have discussed in this part, control plane and data plane. Okay. Now, okay, coming back to this example, over here we are assuming this, we have a serverless compute plane, okay, engine. They are the applications that are, I mean, utilizing Databricks Workspace, where we can control, we can build a way application. We can, I mean, where we have benefits of Unity catalog. We can do the queries through SQL editor, and the cost part of this is maintained by the cloud interface. Okay, this cluster cost or storage cost is maintained by cloud storage. Okay, and these are resources that's utilizing the benefit of the Databricks. So this is the high level architecture. Okay. When we talk about execution from the Spark end, okay, we have I mean, it's divided between driver, workers, and executor. So what is driver node? So driver node is something that runs your application's main function. Okay. When you are, I mean, just build a tag graph and optimize it and select the base craft to run into the memory. Okay. When you talk about the executor, okay, executor is something, I mean, when the actual task are, executor does handle the actual task. So, if you are some partisans, yeah, some partisans code, or the caching or some other calculations code in your query, okay, the executor divides the respective task into, respective task into its memory, where we can where the task where this is basically divided into between different worker nodes. And so we have driver in the top. Driver is with the node to worker node. Okay, and in the worker node we have the executor that runs the task. Okay, it does a data partition, it does the shuffle, so or the query or any kind of filters. So any kind of action that you can call through Spark. Now you'll see at how the partitions. This is a simple example. Like if we have two partitions, like these three executors. So over here we see driver, worker, and executor. So we are diving into the executor part here. Okay. So if, for example, we have two executors. Uh, each executor has one task over here, and this is how the memory is distributed. So suppose task one does take 1 MB of memory allocations, task two takes 1.5 MB, and if we does increase the task, okay, sorry, executors, uh, if it does execute the number of partitions inside the executor, this respective task is distributed inside the multiple executor, which is again inside a node itself. So I hope this is clear. We'll move to the cluster strategy and scaling part over now. Now coming back, like as we have discussed over in this section, like uh, we have discussed about the all-purpose compute cluster and job compute cluster. Okay. Uh, so what's the benefit of all-purpose cluster and job compute cluster? So as we have mentioned in the last slide as well, that into job compute cluster should be used for automated flow. Like if we are building a pipeline and if you want to schedule it on a regular interval, yes, it is a job compute cluster. It does have the benefit that it has low DBU cost. DBU is something Databricks unit cost. So it's a measure of how the cost is measured in the terms of Databricks. Okay, so the more DBU, it will cost you more dollars, and it's based for the production jobs, and that's something that we already discussed. That the schedule for ETL or ELT pipelines. Now, what's the benefit of all-purpose cluster? So in all-purpose cluster, you can manually start, stop, and terminate. The job compute cluster is something that would be triggered once the pipeline is executed. Okay, pipeline will execute the Databricks flow. So suppose if you have a Databricks pipeline, if you have a data factory pipeline, ADF pipeline, and inside ADF you are calling the database notebook. Okay, it will trigger the database notebook, and the cluster associated inside the ADF pipeline should be the job compute cluster. So when you are configuring the ADF pipeline, it should be it's your duty to make sure that the cluster that you are associated should be the job compute cluster, so that it will cost you less money. Okay, and yeah, the all-purpose cluster is based for ad hoc analysis. So if you are doing some analysis from your end, if you're doing some development, if you're debugging something in your personal notebook, personal workspace, you should be using the all-purpose cluster. And the cluster pool is something that maintains the idle instances, like how long the cluster is idle. Okay. If you are creating a new cluster, it's responsible for the fastest startup. Okay. And like it's based for the fast ad hoc analysis and time sensitive jobs. Now, okay. Now here in database, we have benefit of like you can say it while creating cluster. You could define, like if you want to use the auto scaling feature or not. You can define the minimum node and maximum node while creating cluster. What's the benefit of it? So suppose uh, if we have the low load, okay, like if you have defined a cluster with if you have two cluster C1 and cluster C2, okay. Cluster C1 is something that you have created using a fixed node cluster, and if you have defined, like you should be using uh, like 30 like 10 nodes, okay, something like that. Since it's a predefined cluster, okay, it's predefined cluster, like um, and you are using higher node, there's a fixed cost with it, okay. You cannot, with a load, you cannot vary. But suppose if you have cluster C2 and you have set auto scale with minimum node as 2 or maximum as 10, okay. When the load is vary, like if the load is like very low, okay, you could have, I mean, you could utilize this, you could be utilizing this two nodes, okay, and your cost computation should be based on these two nodes only. And in case if you have very high fluctuation, as you can see in this example, like during the high load, it's using the maximum node. For example, 30 nodes you can see. This is DBU, this is the cost, but just for simplicity, you can see like what like right now it's using 10 node, okay, and but the meantime it has the less load. Like if your query does uses the less memory or less compute power, okay, it does scale back to the lower node, and in the simple terms, it does save your cost as well. So that's the benefit of high, auto scaling a cluster by defining it. Now in Databricks, you can also see the logs, like you can see the driver logs, uh, cluster logs, like if so, for example, in this part we have discussed about, not in this part, yeah, this part we have discussed like driver, worker node, and executor. So we can see like what's happening in the driver log. If the cluster is already started or not, if, how long the cluster is getting started. And you can see the Spark UI events as well. This is something you can see in like compute section of Databricks. We'll go through that. Now, what's the benefit of Databricks that you can use? You can build a real-time CDC pipeline. You can build an batch processing ETL pipeline or the real-time streaming. Okay, so this is something example, like over here we are using DLT functionality of Databricks, and this is being used to from bronze to silver transformation. So far, does anyone have any questions? We'll deep dive to Databricks UI now, if we not have any questions from your end.
Yeah, Rajiv, I have one question. So, like in military architecture, you say that what is the difference between that gold and bronze? So, once we got the bronze layer, so it means that it's a lower raw data. Then, what is the difference between the silver layer and gold layer? Whenever we are doing any transformation on that, so it becomes the silver.
Mhm.
Then, what is the
Mhm.
difference between the silver and gold?
Mhm. So silver day is something when you are doing the transformation, right? It is, suppose if we have null values in your table, and you are simply filtering out the record, remove the duplicates, and doing some basic transformation. That's something is a silver layer. Okay, it's a clean data. Okay, but it's untransformed data. Like it is same thing, but the data is untransformed. This is something that you could benefit in your BI dashboard. Okay. Now, what is code layer? Uh, suppose you have a pool of tables and you need some transformation as per business. Okay, you need to do some group by or aggregates for your data, for your end BI dashboard. Okay, so this is a transform data which is business ready, and that's the basic difference between silver layer and gold layer. Does it
Okay,
answer
yeah.
your question?
Yeah, exactly. Thanks.
Okay, no problem. Any other question? Okay, if no, I will move further. So as I mentioned in the start of the course, like you can refer to docs.databricks.com for a basic understand. It's a Bible of Databricks. Like you could uh, go through this endlessly, and it just gives you all the, I mean, all the theory part, like where Databricks is being used, what is data lakehouse, okay, what are the components of Databricks, this all things. How could you sign up for Databricks? Uh, Earlier, database had community version, but now they had, completely wiped out that community version, and they come with a free edition, which has more benefits as compared to community versions. But you need to sign up for this one if you don't want to utilize database free editions workspace. All right. Now we'll move to like I'll just there's something I have this is something from a course. You can go to Uplimit. This is a website, uplimit.com. This is funded by Databricks, and you can enroll in sub course. Okay, I'm utilizing the same workspace just for a demo purpose. Uh, how could you? Just to give you an idea that how does the Databricks UI does look like, and what we do through the Databricks. All right. So this is you can see the hamburger symbol. If you click on it, you will be able to see different sections of the Databricks. Okay. Uh, if you are you can create a new notebook. You can create a new database query. SQL query. You can build a dashboard as well. There are multiple uses of this one. You can, if you want to create a job inside Databricks, like ETL flow, ETL job, and to schedule it on timely basis, you can also do it through the Databricks. This is something where you will be able to see your account. Okay, in through settings you can control uh, if the access part, if you are admin, you can control the access part. Not the admin, so I cannot control, but this is something you can control the access part as well for a particular notebook or something. This is the workspace where all of your data is live. Okay, and you can integrate, as I had mentioned earlier, that you can utilize the Git. You can. This is a best practice to build that repo if you are building some production ready flow pipeline or something notebooks. That should be inside a database a repo. Okay, you can link any database notebook through the repo itself. Inside the Databricks notebook, like I'll just see a simple example just for understanding. Okay, one more thing. When you create a notebook, okay, you have the benefit of either creating a Python, R, or Scala notebook. If we have since this is a dummy account, I'm not allowed to do that. But if you want to trigger run uh, any SQL command, okay, database does have benefit of the magic command. You could say you can use. Suppose if your notebook is based on Python, okay, here you can see the Python notebook. You can change it to convert to SQL, Scala, or R. It's your choice. But suppose if you have a Python notebook and you want to just see it, just do a quick analysis using a SQL query, you can utilize the benefit of the magic command. You can run your query and you can simply execute it. And you have the benefit of running SQL query inside a Python notebook. Okay. Um, we are discussing about the compute part, right? Let's see that if I have the, yeah, I can see. So this is some, Okay. Right now the cluster is there's no notebook associated with the cluster. So suppose if I'm let me trigger a notebook or simply attach one notebook with the cluster. Okay. So now if you go back inside the cluster, you can see that one notebook which is attached with the cluster. In the configuration section, you can uh, like you can change the runtime. I do not have access because it's a dummy account again. But over here you can change the runtime. Okay, if you want to utilize the DBR16 or a database runtime 16 version, okay, you can select what Spark version you want to use inside your cluster. You can define the node type. This is something we're talking about. If you're not utilizing cluster, you should define a time limit. Suppose if you are not utilizing the cluster for 1 hour, okay, and you don't want that unnecessary cost should be associated with the account, you can set the time limit to 60 minutes or something. Okay, you can also define the cluster logs. I mean, how many drivers you want to associate, uh, or you can define uh, right now you'll not be able to see this EY, but you have the benefit of define like how many clusters in autoscale, how many nodes do you want to attach, and how many maximum cluster nodes that you want to attach while creating cluster. Okay. You can add predefined library. So suppose if you want to utilize the benefit of any uh, any existing library. So suppose if you want to utilize the pandas library, okay, you can install this library inside the cluster only, so that by utilizing the cluster, you do not need to install it separately. Okay, you can. I mean, I'm just taking panda as example because uh, panda is something that is pre-installed inside the cluster and you can directly use it while importing. But uh, it's the same with any library that you could do. And over here, you can see the Spark UI, okay, the driver logs, uh, matrix that net house the memory consumption of cluster, CPU utilization, something you can see in this section. Okay. SQLite is, I mean, over here you can run any SQL query. You need to build a data warehouse to run a SQL query inside Databricks Workspace. Okay. So to give you a right now we have a lake house, so you can query any data inside the catalog. Suppose if I'm copying this table, right? Let me go through here. Oh, there's any data we have. Metadata. Okay, right now we do not have any data. So, I mean, because this workspace does refresh every time you create it using this website. So it's created a entire new lab for you. So that's why I don't have any data. But you can simply query using simple SQL command, select a star from, and you can drop down any table and you can run this query. Okay. So we're talking about data catalog. Right now we do not have any table, and see if we have setting function schema. Okay. So we'll be able to see there's something I'm fetching from function schema as we do not have any table inside our data lake. So you'll be able to see the columns like schema, data type. Okay, and this is something I was talking about when we had discussed about schema enforcement. Like it does verify if you are writing data into any table, it does verify uh, the schema type, schema name, and does match with what you are writing in a table or not. Okay. I can associate any tags, predefined tags like suppose data sensitivity or something with your columns or the tables itself. You can see the sample data. You can simply query it. Databricks has also added a benefit of some like AI features, like you can simply query something and it will give you the result. Okay, so it will take some time to load. Meanwhile, if you query this example, okay, how many unique entities per catalog we have, okay, it will give you the result by itself. It will give you the query, and if you run the query in here, you can do the same in SQL editor as well. It will give you the result, like the main catalog name and guarantees one. Okay, so there's something benefit of catalog that you can do a quick analysis. You can see that schema type, data type. You can see the permissions of a data of on a table or schema level. Okay, so for example, over here you can see the all account is the select permissions on this catalog. You can see the same in the schema level. Okay, what permissions do we have in the schema level? Since schema level, you can see that all account users has the schema the same permission that's which is inside a table. The same is associated with the schema as well. But in production, we can uh, predefine what permission do you want to based on a group, try to a group of people on a schema or a table level. So this is something possible. In jobs and pipeline, you will be able to see if any pipeline that you have automated through ADF or if you have automated through Databricks Workspace itself, you'll be able to see all jobs information here. Right now, since we do not have any triggered any pipeline or do not have created any pipeline, not able to see that. But it's something we already discussed. Data marketplace is something you can just I personally do not have used much of it, but this is something that database does come, like if you want to integrate with Power BI, if I have tried, you can utilize the Databricks marketplace. The skill editor we have just seen, like you can query any, so same thing that we have used earlier. Let me see if we can do the information schema here. Now, if you want to query this table, okay, I'm run all. You need a lake house for this one right now. In this uh, notebook, we have a lakehouse test with the name test Postgres. You can trigger it and it will give you some result. Okay. My role does not exist in this particular database, so it will not trigger. Oh, wait. But we can refer to the query sections and what query we have triggered just right now. Okay, it will come over here. If you want to build a dashboard just for quick visualization, you can do in database dashboard itself. Okay. Genie I do not have used personally, so I don't have much idea about it, but you can explore around the same things. If you want to set any alerts for like a notebook completion or something, you can do it using Databricks alert feature. You can create alert. You can create alert. Okay, I think let's go back to alert 7. Okay, you can trigger write any query. You can schedule it from this part. Okay, when do you want to schedule to trigger any? So suppose if you want to get a count on a high level, like if you have a financial data and to see that you want to just check the purchase priority variance, like if you want to check if the price that you are paying to the vendor, if that's match, uh, like what's the maximum price that we are paying to the vendor as compared to market price. So you can run a query. You can schedule it on if you want to check on it on monthly basis, like from a large fact table. If you want to query and if you want to check this on monthly basis, you can create a scheduler and you can add alert around it. So this will, I mean, you'll get an alert. You can say it like, where do you want to, like, you can get an email alert if based on condition, like, or if you want to just get the records, you can get that it using the mail alert as well. Okay. To carry is something we have seen earlier. SQL warehouse, right now we have test GNI. They will not be able to see the warehouse here. But if you have permissions, you'll be able to see, like, or you're able to create a SQL warehouse using this section. And this is something that you can associate with your SQL editor to run any query as well. All right. This AI ML playground I do not have used personally, but you can walk through it and see that you can create agents, you can create ML model, and utilize the benefit of Databricks. Yeah, that's all from my end. Feel free to ask if you have any questions or if something is not clear to you.
Anyone having any questions? All right. That's all, Ranjiv. Thank you, everyone. Thank you for the session.